Welcome back. In front of us, we have a friction problem, and it reads, a body of mass 16 kilograms rests on a rough plane inclined at 30 degrees to the horizontal. The coefficient of friction between the body and the plane is 1/4 root 3. If the body slides down the plane from rest, what is the magnitude of acceleration if no external force is applied, if a force of 40 newtons is applied parallel and down the plane? Solution. Here we are dealing with acceleration. Okay, we have a body that is resting on an inclined plane and it is accelerating down the plane. The first question wants us to find the magnitude of the acceleration if there is no applied force. The second question wants us to find the magnitude of acceleration if a force of 40 newtons is applied. Let's try to solve for the first case. And the first thing I will try to do is to bring the diagram. So this is the diagram, and it says a body of mass 16 kilograms. So the mass of the body is 16 kilograms. That is resting on an inclined plane that is inclined at 30 degrees to the horizontal. If we should complete the diagram, we need to include the forces that we have. There is a force that will always act downwards, which is the mg sine theta. Okay, we are informed that this body is sliding down the plane, so it means the frictional force have to act in the opposite direction. The direction of friction will be up the plane. Okay, that is F. We can complete the diagram by indicating the normal reaction and the weight. Okay, this is the normal reaction R, and the weight will come vertically downwards. So this is the first case that we have. Okay, so since the body is accelerating down the plane, it means that mg sine theta must be greater than the frictional force. Otherwise, the body would not go down the plane, right? So to find the net force, we said that it is equal to mass times acceleration. So what will be the net force is mg sine theta, so minus the frictional force, that will give us mass times acceleration. Okay, so there is no external force for the first question. Now we're going to have mg sine theta minus frictional force is given as mu r. This is equal to ma. So we're going to have mg sine theta minus mu r is mg cos theta. That is the normal reaction. So this is equal to ma. What I can do here is I can factorize m. So that will be m into g sine theta minus mu g cos theta is equal to ma. So I can cancel m. Therefore, we'll have g sine theta minus mu g cos theta is equal to acceleration. So acceleration is equal to g sine theta minus mu g cos theta. If you want, you can factorize g out. If you want, you can just continue solving like that. So by substituting the value, gravity is 10 times sine of the angle is 30 minus the coefficient of friction given in the question is 1 over 4 root 3. So that is the same as root 3 over 4, because 1 times root 3 is root 3. So we're going to write root 3 over 4 multiplied by gravity is 10 cos 30. So that is going to be 10 sine 30. So 10 sine 30 is 5 minus root 3 over 4 times 10 cos 30. That will be 3.75. So 5 minus 3.75 is 1.25 meters per second squared. So that is the magnitude of the acceleration when there is no applied force. Okay, that answers the first question. Moving on to the second question, we want to find the acceleration when a force of 40 Newton is applied parallel and down the plane. So let's try to draw a diagram for that. Again, we have our diagram here. It is a body of mass 16 kilograms. Okay, that is on a rough plane inclined at 30 degrees to the horizontal. We said that we have a force that is always acting downwards, which is mg sine theta. And if this body is going to accelerate downwards, we're going to have frictional force that is going to act in the opposite direction. So, but there is an additional information that is given. We are given an applied force of 40 newtons that is acting parallel and down the plane. So let's try to indicate that. Okay, we have an applied force of 40 newtons. Okay, you can write P if you want. So P is the applied force. So we can complete the diagram by indicating the normal reaction and the weight. So that is the normal reaction R, and we have the weight coming vertically downwards. All right, so if this body is to accelerate down the plane, then the forces that are acting down the plane must be greater than the opposing force, which is the frictional force. So there will be a net force. We know that from Newton's second law of motion, the net force is equal to mass times acceleration. So what will give the net force? We're going to have the downward forces, which are P plus mg sine theta minus the frictional force, that will be equal to mass times acceleration. So that will be P plus mg sine theta minus frictional force is given as mu r. This is equal to ma. So that will be P plus mg sine theta minus mu r is mg cos theta. So this is equal to ma. Okay, now we can go on and substitute. The applied force is 40 newtons plus the mass is 16 kilograms multiplied by 10 sine 30 minus the coefficient of friction is root 3 over 4 times the mass is 16 times gravity is 10 cos 30 is equal to the mass is 16 kilograms multiplied by A. Okay, so that will be 40 plus 16 times 10 is 160. So what is 160 sine 30? That is 80 minus 16 times 10 is 160. So 160 cos 30. If you multiply it directly with root 3 over 4, you will have 60. So this is equal to 16 times a is 16a. 40 plus 80 minus 60 is 60. This is equal to 16a. To find a, you divide both sides by 16. So therefore, acceleration is 60 divided by 16, and that is 3.75 meters per second squared. And that answers the question. Thank you very much for watching this video. Please subscribe to the channel, like and share the video.